This example, given to you Laplace transformation of zt is equal to zs, okay, because now you have equation of z in terms of t, therefore your Laplace transformation of zt is the capital Z in terms of s, okay, and given to you z0 or z0 is equal to 5 and z prime not is equal to -4, okay, and you need to find the Laplace transformation of 6d square z dt square plus 2d z dt minus z. Okay, so let's write our equation here. Okay, this is what we want to find. Therefore, what you want to find is actually the Laplace transformation of 6z double prime t. Okay, because this one is the second derivative, therefore you have z double prime t plus with 2z prime t minus with z. Okay, and if you can remember, by using the properties of linearity, you can write this one also as the Laplace transformation of 6z prime t plus with Laplace transformation of 2z prime t plus with Laplace transformation of z minus, okay, this one is minus. Okay, this one is by using the property of linearity where we give them each term. Okay, so now if you can see here again, okay, 6 here is only a constant, 2 here is also a constant. You can bring it out of the integrals or out of the Laplace transformation. So you can write your equation is equal to 6 times with the Laplace transformation of z double prime t, okay, plus with 2 Laplace transformation of z prime t minus with the Laplace transformation of z. This is what you want to find. Okay, so what is the method now is, what is the Laplace transformation of z double prime t, what is the Laplace transformation of z prime t, and what is the Laplace transformation of z. Okay, but given to you here, Laplace transformation of z is equal to zs, therefore later we will substitute it here. Now what we want to find is the Laplace transformation of z prime t. Okay, and you know that how many terms that you have is the number of derivative plus 1. Here you have 2 derivatives, therefore plus 1 you have 3 terms. So your term will start with zs or zs, okay, minus with followed by z0. Okay, you have 3 terms. Another one is z prime naught. Okay, don't forget that in front of them you need to put s, and s start with the power same with derivative. Here you have 2 derivatives, therefore s start with to the power of 2, followed by s to the power of 1 here, and s to the power of 0 behind here, but s to the power of 0 is equal to 1, therefore no need to write it here. Okay, so here is your Laplace transformation of z double prime t. What is the Laplace transformation of z prime t? Okay, because we have 1 derivative, therefore we have 2 terms. The first term start with zs again, followed by z0. Okay, so you have s here, s to the power of 1, s to the power of 0 here is equal to 1. So this is the Laplace transformation. Okay, so now you need to substitute this one inside this one, and you need to substitute this one inside this one. Let's do that. Okay, so we have 6 times with s squared zs. Z must be capital. Okay, don't forget z is a Laplace transformation, therefore it must be capital zs, minus s z0 minus with z prime naught. Okay, plus with 2 times your Laplace transformation of z prime, so you have s zs minus z0. Okay, minus with the Laplace transformation of z is equal to zs here. Okay, and before this, it's given to you that z0 is equal to 5 and z prime 0 is equal to 4. So let's substitute it directly here. Okay, where here you have z0 is equal to 5 and z prime 0 is equal to -4, and here you have z0 is equal to 5. So let's substitute before we expand. what you will have here is 6s square zs minus z0 is 5, so you have 5s minus z prime 0 is negative 4, so you have minus negative 4 plus with 2 s zs minus z0 is 5, okay, minus with zs. Okay, now after you substitute, let's expand this equation where you need to times 6 with s square zs, so you will have 6s square zs. 6 times negative 5s, you have negative 30s. 6 times positive 4, you have positive 24. Plus with 2 times s zs, you have 2s zs. 2 times negative 10 and negative 5, we have negative 10 minus zs. Okay, so now is the matter of simplify our equation here. So you have to collect the same term. You have zs here and you have zs here as well as this one. So what you will have in your bracket is 6s square plus 2s minus 1 zs out of the bracket. Then you have minus 30s here plus 24 minus 10 is plus 14. So this one is the Laplace transformation of your equation. Let's see one more example on the Laplace transformation of derivative. Okay, so given to you that Laplace transformation of xt is xs, x0 is equal to negative 2 and x prime 0 is equal to 8. So now you have been asked to find the Laplace transformation of 5t squared x dt squared minus 3dx dt plus 2x. So what you need to do is you need to find what is the Laplace transformation, okay, for 5x double prime t, because we have second derivative here, minus with 3x prime t plus with 2xt. Okay, so it also can be written as 5 Laplace transformation of x double prime t minus with 3 Laplace transformation of x prime t plus with 2 Laplace transformation of xt. Okay, so now what we need to do is we need to substitute what is our Laplace transformation of x double prime, Laplace transformation of x prime, and also what is the Laplace transformation of xt. Okay, so we have learned before how to do a Laplace transformation of all these derivatives. So let's directly substitute. So what we will have here is 5. Okay, and the Laplace transformation of second derivative of x will be s square xs minus with s x naught minus with x prime, okay, minus with 3, and the Laplace transformation of the first derivative will be xs minus with x naught plus with 2, and the Laplace transformation of xt is given by xs here, so xs. Okay, so now before we want to continue, let's substitute, because we are given here that the value of x naught is equal to negative 2 and value of x prime naught is equal to 8. Okay, so it's easy if we directly substitute so that we can simplify our equation here. So what you will have here is 5 s square xs minus with x times x naught is given to be negative 2, minus with x prime naught is equal to 8. Okay, minus with 3, so we have x here, minus with x naught is equal to negative 2 plus with 2 xs. Okay, so now let's open the bracket. So here we times with this one also time with this one, and this one is also time with this one. Negative 3 here, time with xs, and times with positive 2 here. So what you will get in your equation is 5s square xs, okay, minus is plus 2 times 5 is plus 10s. So minus 8 times 5 is minus 40. So you have minus 3s xs here. Plus minus is plus, plus minus is minus again with 6, plus with 2xx. Okay, so let's collect the same variable together. So what you will have here is xs here, xs here, and xs here. So let's collect them together. So we can put it as in the bracket 5x squared minus 3s plus with 2, outside of the bracket is the variable xs. Okay, then we have here we have negative 40 that can be simplified with negative 6, given you negative 46. Therefore the rest of the equation can be written as plus 10s minus 46. So this is the Laplace transformation of the function that have been asked here. Okay.